All the bones in the body that support it help it to move and protect internal organs. Skeletal system. The skeletal system is the body's framework of bones that supports movement and protects vital organs. Imagine trying to build a sturdy bookshelf to hold your favorite books, but lacking the right framework to keep it upright and stable. Just like how a bookshelf needs a strong structure to support the weight of books and withstand movement, our bodies rely on the skeletal system to provide support, facilitate movement, and protect vital organs. In this analogy, the wooden frame of the bookshelf represents the bones that give shape and strength. The screws and joints are like the joints in our body aiding in movement, and the back panel serves as a shield, much like how our ribs protect internal organs. A strong, flexible connective tissue found in skeletons. Cartilage is a smooth tissue that cushions joints and supports some body structures. Imagine trying to balance a stack of books on a squishy pillow without them toppling over. Just as the pillow provides a soft yet supportive base that keeps the books stable and prevents them from slipping, cartilage acts as a cushion between bones, providing both flexibility and strength to the skeleton. The pillow's ability to mold and hold the books without collapsing is akin to cartilage's role in joints, where it absorbs shock and allows smooth movement, preventing bones from grinding against each other. A point where two or more bones meet, joint. In science, a joint is where bones connect in the body, allowing for movement and flexibility. Imagine you're organizing a dinner party and need to figure out where everyone will sit. Just like deciding the seating arrangement to ensure smooth conversation and interaction, a joint is where two or more bones meet, allowing for movement and coordination. In both scenarios, the key is to create a point of connection that facilitates interaction, whether it's guests at a table or bones in a body. A tough band of tissue that attaches bones to muscles. Tendon. Tendons are strong cords that connect muscles to bones to help move our body parts. Imagine trying to hang a heavy picture frame on a wall using a thin, flimsy string. Just like a strong, reliable cord is needed to securely hold the frame in place, tendons act as the sturdy connectors that attach muscles to bones, ensuring efficient movement and support. In this analogy, the wall represents the bone, the picture frame is like the muscle, and the tendon is the strong cord that holds them together, enabling your body to function smoothly without falling apart. The ratio of the output force to the input force in a machine is the mechanical advantage. It tells you how much a machine can multiply your effort to make tasks easier. Imagine trying to open a tightly sealed jar with just your bare hands. Just like using a rubber jar opener to gain a better grip and increase your hand's effectiveness, mechanical advantage is about using a machine to multiply your input force to achieve a greater output force. In this scenario, your hand is the input force, the rubber jar opener is the machine, and the increased grip and torque you gain is the output force that makes opening the jar easier, illustrating how mechanical advantage allows you to exert less effort for more significant results. A tough band of tissue that holds bones together at a joint. Ligament. Ligaments are strong, flexible tissues that connect bones at joints, helping to stabilize and support movement. Imagine trying to keep a stack of books from toppling over without using any tape or glue. Just like books in a stack need a way to stay aligned and stable, our bones require a system to hold them together and maintain structure at the joints. Ligaments act as the strong yet flexible bands that keep our bones in place at the joints, much like how a carefully balanced stack of books relies on the alignment and pressure between them to stay upright. The hard outer layer of a bone. Compact bone. It is the dense, strong part of the bone that provides support and protection. Think about when you need to carry a fragile item, like an egg, while ensuring it doesn't break during transport. Just like you might wrap the egg in a protective shell or case to prevent it from cracking, your bones have a hard outer layer known as compact bone to protect the vulnerable interior. In this analogy, the protective case is like the compact bone, providing a sturdy and durable shield around the more delicate inner structures, much like how we protect fragile items to ensure their safety. A muscle that is not under conscious control, like the heart muscle. Involuntary muscle. Involuntary muscles are muscles that work automatically without you thinking about them, like the heart pumping blood. Imagine you're trying to manage the notifications on your phone. Some pop up automatically without you having to do anything. This is similar to how involuntary muscles work in your body, functioning without conscious effort, just like those automatic notifications. Your heart muscle is like those notifications. It keeps beating and working in the background without you having to consciously think about it, ensuring your body operates smoothly. Much like your phone, staying updated with information you need. A muscle that is under conscious control, like the arm or leg muscles. Voluntary muscle. Voluntary muscle is a type of muscle that you can control at will, like when you decide to move your arms or legs. Imagine you're trying to decide what to watch on TV, and you have the remote control in your hand. Just like choosing a channel requires your conscious decision using the remote, using voluntary muscles like those in your arms or legs requires your deliberate control. The remote is like your brain sending signals, and the TV is like your muscles. Just as you press buttons to change the channel, you send signals to your muscles to move, allowing you to consciously decide your actions. A muscle that is attached to the skeleton. Skeletal muscle. Skeletal muscle is a type of muscle that helps move bones and is under our control. Imagine trying to move a heavy piece of furniture across a room without any help. Just like how you rely on your arms and legs to push and pull the furniture, your skeletal muscles are responsible for moving your bones to perform actions. In this analogy, the furniture is like your body. The arms and legs are the skeletal muscles, and the floor represents your skeleton. Without the muscles exerting force on the skeleton, movement would be impossible. An involuntary muscle that controls internal organs like the stomach and intestines. Smooth muscle. Smooth muscle is a type of muscle that works automatically to manage movements in internal organs without conscious control. Imagine trying to keep a busy train station running smoothly without being able to directly control each train. Smooth muscle functions much like this because it operates involuntarily to manage the movement and function of internal organs without our conscious direction. Just as the trains continue to run on schedule through automated systems that work in the background, smooth muscles ensure your stomach and intestines continue to process food and nutrients efficiently, maintaining your body's internal operations seamlessly. An involuntary muscle found only in the heart. Cardiac muscle is a special type of muscle that makes the heart pump blood without us having to think about it. Imagine you're trying to get a good night's sleep, but your phone keeps buzzing with notifications, waking you up every few minutes. This situation is similar to the cardiac muscle because, just like you can't control the notifications that disturb your sleep, you also can't consciously control the cardiac muscle as it beats continuously without your input. The connection is that both the buzzing phone and the cardiac muscle operate independently of your conscious control. Your phone keeps buzzing to keep you informed, and the cardiac muscle keeps contracting to keep you alive. The outer, thinnest layer of skin that is made up of dead cells. Skin epidermis. The epidermis is the top layer of your skin that protects your body by creating a barrier to the outside environment. Imagine the frustration of having to clean up the fallen leaves in your yard every autumn. Just like those leaves, the epidermis is a layer made up of dead cells that constantly need to be shed and renewed. Just as leaves protect a tree by providing shade and eventually fall to make way for new growth, the dead cells in the epidermis protect the underlying layers of skin and are continuously replaced to maintain healthy skin. The second layer of skin that contains blood vessels, nerves, sweat glands, and hair follicles. Dermis. The dermis is the skin layer that supports and nourishes the outer layer while housing important structures like hair follicles and sweat glands. Imagine trying to organize a large, bustling kitchen during a busy dinner service. Much like this kitchen, the dermis is a complex hub where essential activities occur, including circulation, sensation, temperature regulation, and growth functions. Just as the kitchen has chefs, blood vessels delivering ingredients, waiters, nerves communicating orders, ovens, sweat glands regulating heat, and pantry shelves, hair follicles storing supplies, the dermis manages and supports the skin's vital operations, ensuring everything runs smoothly. The organ system made up of muscles that help the body move. Muscular system. The muscular system consists of tissues that contract and relax to move parts of the body. Imagine trying to organize a group of friends to move a heavy piece of furniture. In this scenario, each friend plays a role similar to a muscle in the muscular system, working together to achieve movement. Just like coordinating friends to lift and navigate the furniture, the muscular system involves various muscles contracting and relaxing in a coordinated effort to move the body. Each muscle, like each friend, contributes to the overall task, ensuring smooth, efficient movement. The system, including the skin that separates the body from the outside environment. Integumentary system. The integumentary system is the body's first line of defense, protecting it from harm and helping regulate temperature. Imagine you're at a bustling, crowded party and you want to keep unwanted guests from entering your personal space without being rude. Just like how you use your body language and positioning to create a boundary, the integumentary system, including your skin, acts as a barrier that separates and protects your body from the outside environment. Your skin serves as a protective shield, much like your subtle gestures at the party, ensuring that only the right elements, like nutrients and warmth, are allowed in while keeping harmful intruders at bay. The glands and hormones that regulate body conditions and growth, like the thyroid. Endocrine system. The endocrine system is a network of glands that produce hormones to control many important body functions. Imagine trying to manage the temperature in your home with multiple thermostats spread throughout different rooms. Just like you adjust each thermostat to ensure the right temperature for comfort, the endocrine system uses glands and hormones to regulate body conditions and growth. In this analogy, the glands are like the thermostats, each releasing hormones or temperature changes to maintain the overall balance and comfort of the body, similar to how thermostats ensure the right environment in your home. One of the 33 bones that make up the backbone. Vertebrae. Vertebrae are the individual bones that stack to form your spine, supporting your body and protecting the spinal cord. Imagine trying to stack a set of dominoes into a tall, stable tower. Each domino needs to be precisely placed to ensure the entire structure doesn't topple over, similar to how each vertebra in our spine must be perfectly aligned to support our bodies. Just like how a single misplaced domino can cause a chain reaction and collapse the whole tower, A misaligned or damaged vertebra can disrupt the function of the spine, leading to pain or injury.